All right, let's take a look at number 5 from section 8.3. A toy rocket is launched from a platform 2.1 meters above the ground in such a way that its height, h in meters after t seconds, is given by the equation h equals negative 4.9 t squared plus 14.0 t plus 2.1. How long will it take for the rocket to hit the ground? All right, so the first thing we need to realize is when the rocket hits the ground, height is 0, so h is 0. And that's a key observation for the problem. So we're going to take the quadratic expression, negative 4.9 t squared plus 14.0 t, we'll just write that as 14t, plus 2.1, and we're going to set that equal to 0. We want to know what t value gives us a height of 0. Now, one of the things I'm going to do here, because I always like to have a positive leading coefficient, that's not absolutely necessary, but that is my preference. So I'm going to multiply the equation by negative 1. And I would also be doing that on both the left and the right side of the equation. So this gives me the equivalent equation, 4.9t squared minus 14t minus 2.1 equals 0. And I'm going to use the quadratic formula on this. A will be 4.9, B is 14, and C is negative 2.1. So I'm going to use that information in the quadratic formula, which tells me the variable of the equation, which in this case is t, is negative b, which is negative 14. So my b is negative 14, plus or minus the square root of b squared, so I square negative 14, minus 4 times a, which is 4.9, times c, which is negative 2.1. And this is all divided by 2a, which is 2 times 4.9. And so my calculator is going to help me with this. And I see that this is 14, negative 14 is 14, plus or minus the square root. When I square negative 14, I get 196 minus a negative 41.16, and this should be 196 here. So that double negative turns into a positive. This is all over 9.8. So I wind up with t equals 14 plus or minus the square root of 196 plus 41.16 all over 9.8, which is 14 plus or minus the square root of 237.16 divided by 9.8. Alright, and I'm going to have to split this into the two separate t values. One t value is 14 minus the square root of 237.16 over 98. And I'm going to let my calculator give me an approximation for that. And I get a negative 0.0143. And the key about that, since t represents time, this is not applicable to the problem. Now I'm going to look at the solution where t equals 14 plus the square root of 237.16 divided by 98. We'll do that calculation. And in this denominator, of course, we have 9.8, not 98. We had that previously. And this works out to give us not an approximation this time, but an exact value of 3. So it takes, we actually have the sentence already set up for us. The toy rocket will hit the ground after 3 seconds. So that's our final answer on that one.